Alright, welcome. In this video, I'm going to be working Algebra 2 Quiz 1.1, which is over one variable equations. And I'm going to be working both forms. And we're going to start by finding the values of x that make the equation true, and we're going to show the work that leads to our answer. Okay, so we're going to find the values of x by solving this equation by being fair to both sides, doing the same thing to both sides, right? So, you know, it doesn't really matter if we start with the x's or with the numbers. I might, because I know that a half is bigger than a third, I'm going to want to subtract a third from both sides. And maybe I'll start with that. So I'll subtract 1/3 x from both sides. Okay, and then, nothing will happen to the 4 or the -6. I'll just lose this. A half minus a third. Well, a half is 3/6, and a third is 2/6, right? If we're going to subtract these things, we need a common denominator. And we know that 3/6 minus 2/6 is going to be 1/6. So I know that I'm going to have 1/6 of x when I do 1/2 x minus 1/3 x. And then, okay, to try to get x by itself, I'm going to need to get rid of this 4. So I'm going to subtract 4 from both sides. Okay, -6 minus 4 is going to be 10. No, -10. And then that's going to be 1/6 of x. Okay. Now I'm going to have to multiply both sides of this equation by 6. Okay, 6 times the 6th of x is going to be 1x, and then that'll be equal to -10 times 6, which is -60. Okay, so x equals -60. All right. And on the second one, for what values of a will the equation have no solution? Okay, no solution is going to end up needing to be like, you know, something like 0 equals 1 or something like that. But first we're going to have to distribute here. So 2 times 3x is going to be 6x, and 2 times 5, that'll be 10. And I'm going to solve this one a different way from how I solved it maybe if you were looking at my key when you were in my class grading somebody else's quiz. I'm thinking I'm going to actually, you know, try to maybe add this 3x to both sides so that I can know that I need to have the same number of x's on both sides. I saw somebody's paper that did this, and I thought that was a much more sensible way to do it. So I'm going to add 3x to both sides. And I'll have 9x plus 10 equals ax plus 5. And now if I had, you know, 9x plus 10 equals 9x plus 5, I know that would come back no solution because I'd subtract 9x from both sides and be, oh, 10 equals 5. That's not true. Okay, so now I know that a has to be that 9 because they have to match up, right? The number of x's has to be the same, but the numbers have to be different for that no solution. Okay, so I'm going to say that a needs to equal 9. Okay. This one, we've got, okay, Alan charges $200 to come out to service the elevator and $50 an hour. Okay, so I'm going to just kind of write an A here. For Alan, it's 200 regardless of how many hours. So it's just a flat 200 plus 50 times the number of hours, which is going to be x. So 200 plus 50x. And then Bernard is going to be $80 plus $65 times the number of hours. That's going to be his total charge. Okay. And we want to know, where is Bernard greater than Alan? So I'm going to just set up an inequality. Okay, Bernard is greater than Alan. And I'm going to plug in over here. 200 plus 50x is greater than 80 plus 65x. Now I'm going to just solve this inequality. Okay, I know there's a lower number of x's on this side, so I'm going to want to subtract that number of x's. But maybe I'll start with the numbers here. I'll start with subtracting 80 from both sides. 200 minus 80, that's going to be 120, plus 50x is greater than 65x. And then I'm going to divide, or pardon me, I'm going to, right, I've got x's on both sides, so I need to subtract some number of x's to have only x's on this side. So I'm going to subtract 50x because I've got added 50x here also. Okay, and that's going to be 120 is greater than 65 minus 50. That would be 15x's. Okay. I'm going to need some more room, so I'm going to come up here. And I'm going to need to divide both sides by 15. Now I know how to do 15 divided by 15. 120 divided by 15, I think we can count by 15s. 15, 30, 45, 60. We know that 60 is half of 120, so it's going to need to be 8. Okay, that's how I would do that without a calculator. I think in my sections I allowed the use of a scientific calculator on this quiz for basically this problem. Okay, but I know that it's going to be 8 is greater than x, and that's a perfectly fine response for me. I oftentimes would switch this around and say, okay, well, x is going to be less than 8. Okay, but this would have been fine, at least in my class. Let's flip over to the back side. Okay, the perimeter of the rectangle is 50. What's the value of x? Okay, so I've got, this is also going to be 3x plus 1 because it's a rectangle, and this will also be 2x minus 7. So I know that I've got two 3x plus 1s and two 2x minus 7s, and together they all add up to 50, right, because the perimeter is 50. And now I'm going to just try to solve this equation. So I've got 2 times 3x is going to be 6x. 2 times 1 is 2. Plus 4x minus 14 is equal to 50. And I'm going to need to combine like terms, right? I've got x's, 6x plus 4x, that's going to be 10x. And then numbers, I've got positive 2 and negative 14, that'll be minus 12. And that's going to be equal to 50. And then I'm going to add 12 to both sides. I'll have 10x equaling 62. And then I can divide both sides by 10, and I could say, you know, pardon me, I was going to show that. And then I would see, okay, you could say x is 6.2. You could say x is 62 divided by 10. You could say x is 31 divided by 5. If you want to reduce that fraction, it really doesn't matter. It's not a big deal. Okay, I'm going to just say maybe x equals 6.2, because I know that was the most common response I saw in the quizzes from my classes that I was looking at. But just to be clear, 62 over 10 is the same number, and I would be perfectly fine with that. What I would prefer you not do is give me a mixed number, 6 and 2/10 or 6 and 1/5, because we're going to a place eventually where mixed numbers are frowned upon, where they can be looked at as multiplication. I don't want anybody to be confused about your work, right? So we're going to avoid mixed numbers in my class. And okay, we want infinitely many solutions, so that's going to be 2a minus ax plus b equals negative 1 plus 2x. You know, this one's a little tricky, and that's why I kind of trained y'all on it before the quiz. But I'm just going to remind you about this. We got to have the same number of x's on both sides and the same number on both sides. And I only see one place where x's are coming in on the left side. So I know that this negative ax needs to be the same as 2x. Okay, I can divide both sides by x, provided that x isn't 0. But we're really not concerned with the value of x because we want it to have infinitely many solutions. And so, or you could just be like, okay, negative ax equals 2x. Okay, a is going to have to be that negative 2, which I think is a better way of solving it with our eyes. Okay, and then past that, I've got, oh yeah, 2a is going to be negative 4. Okay, so that would be plus 2x plus b equals negative 1 plus 2x. And so, whereas, you know, before I had set these two things equal, now I'm going to need to be taking the numbers and setting them equal to negative 1. Okay, so I'll have negative 4 plus b equals negative 1, and that's feeling like I'm going to add 4 to both sides, and b will equal 3. Or that's another one we could probably solve with our eyes. And so I'm going to say the solution is a equals negative 2 and b equals 3. Okay. Now we're going to, the last problem on this form, we're going to solve this inequality. Okay, so I'm going to start by, we just got to be fair to all three sides. And we got to remember that if we multiply both sides of the inequality by a negative number, it's going to reverse the direction. I don't think that's going to happen here because I don't see any negative numbers happening, but, you know, just worth reminding you. So I'm going to start by multiplying all three sides by 3. Then subtracting 5 from all three sides. Is pen running out? I hope not. Yeah, we're going to need a new pen. And negative 3 minus 5 is negative 8. And 3 minus 5, that would be negative 2. Now I'm going to divide everything by 2. And no need to worry about the direction of the inequality because 2 is a positive number. And so negative 8 divided by 2, that's negative 4. Less than x is less than negative 1. Okay. So if I was going to write this as an inequality, that would be negative 4 to negative 1, just like we had. Okay, an interval is with the parentheses or with the brackets. Okay, I know that these are both strictly less than, so that translates to parentheses in the interval world. So it's going to be negative 4 to negative 1. We're not including negative 4, so it's a parenthesis. We're not including negative 1, so it's another parenthesis. And then the sketch would be, okay, from negative 4 up to negative 1, as part of the number line, we're shading on the interior of that interval, right? And we leave the open circles because it's strictly less than, and we see the parentheses. It's all the same idea. Okay, that's it for Form A. Let's move on to Form B. All right, we're going to find the values of x that make the equation true, and we're going to show the work that leads to our answer. Okay, and if you just watched me work Form A, I'm going to work Form B as if I have not worked A, because there might be somebody that just skips straight to B, because that's the form they took in class. Okay, so I'm going to solve this by being fair to both sides of the equation. Whatever I do to one side, I'm going to do to the other. If I, say I'm trying to, maybe I'll start with the numbers. I'm going to add 5 to both sides to clear out that minus 5. We're going to do the same thing to both sides, so I'm going to have negative 5 plus 5, that's 0. So we'll just have 3/10 x. 4 plus 5 is 9, and because I know I'm going to eventually have to do some subtraction, I know I need to get into the tenths world. So I'm going to, instead of writing 1/5 x, I'm going to say, okay, how many tenths is 1/5? That's 2/10. I'm going to say that's 2/10 of x. And that will make it easier when I go to subtract 2/10 of x. They'll see, oh, okay, 3/10 of x minus 2/10 of x, that's just going to be 1/10 of x. So 9 is equal to 1/10 of x. And I'm going to multiply both sides, not by 9. Right? That wouldn't make any sense. That wouldn't get rid of the 1/10. Yeah, I need to get rid of that 1/10, so I'm going to multiply by 10 over 1. Which is multiplying by 10, not 9. So then I'm going to be fair to both sides, and now I'll see that 1x, that's going to need to equal 10 times 9, which is going to be 90. All right, when will this equation have no solution? Okay, I'm going to start by distributing, because you can tell that's what needs to happen when you see that parentheses and the number on the outside. Okay, so 4 times 3x, that's going to be 12x, plus 4 times 5 is 20. Is going to be equal to ax plus 4x plus 5. Okay. And I saw a better way of solving this when I was looking at students from my class's responses. I had been saying, all right, I need to combine ax and 4x and get 12x. And that's valid. If that's how you see the problem, that's how you should solve it. But I kind of like this approach better. I'm going to start by subtracting 4x from both sides. And then I'll get 8x plus 20 equals a times x plus 5. And I know that if I'm going for no solution, I need it to be 20 equals 5, right? So I know I need to have the same number of x's on both sides, so that means that a needs to equal 8. And I think that's a better way of solving it. Okay, no. I don't know why I keep just writing down the wrong number. A needs to equal 8, because then I'd have 8x plus 20 equals 8x plus 5, and if I subtracted 8x from both sides, that would be 20 equals 5, and we know that's an equation that doesn't have any solution. Okay. We've got two guys that can service your elevator. I'm going to write an expression for both of their charges in terms of how long they spent. Okay, so Alan charges $200 to come out and $50 for labor. Okay, so the $200 is always there. It doesn't care how many hours you work if X is the number of hours that they're working. What does matter is the $50 per hour, so that's why it's plus 50X. And then Bernard charges $60 to come out plus 85X. Okay. And we're going to find the values of X for which Bernard is greater than Alan. Okay. So I'm going to set up Bernard greater than Alan, plug in on B and A. B is 60 plus 85X. It's got to be greater than 200 plus 50X. I'm worried I didn't set this up right when I did this one last time. Bernard greater than Alan. Yeah, I definitely messed that up. Oh, goodness. Okay, that's troublesome. Going back to that problem on Form A, right? It says Bernard is greater than Alan, but I copied it down wrong, right? B needs to be over here, and A would need to be over here. The rest of the solving wouldn't be any different, so I know it's just going to like reverse the direction of the inequality. That was really what I messed up, because this is Alan, and that's Bernard, and it just needs to be less. So I'll show you how you can fix it if you realize, right? All of these need to be, I never divided this inequality by a negative number, so it's just going to reverse the direction of everything, I think. But if Bernard is greater than Alan, I need that, and then it's going to stay like that. Okay, and if X is greater than 8, I need to write that this way. All right, pardon me, that was a pretty bad error, but not the worst I've made. Okay, and not worth re-recording this video 17 minutes in. Not going to happen. So Bernard greater than Alan, I've got it right this time. Okay, the numbers are slightly different. I think it's the per hour charge is different, and so we're going to start by subtracting 60. And that will be 85X greater than 200 minus 60 is 140 plus 50X. Okay, there's fewer X's over here, so I'm going to subtract them. Okay, 85 minus 50, that's going to be 35X is greater than 140. I'm going to divide both sides by 35. You know, I'd be like, I can't divide 140 by 35, but I think you can. Because you know what 35 times 2 is, right? That's 70, half of 140. So it's going to be 35 times 4 is 140. Okay, so X is going to need to be greater than 4. Okay, on the back side, we've got this parameter problem. And hopefully this was an easy one for you. Kind of like playing on your experience in geometry class and just what you know about perimeters and rectangles and stuff. So I've got 2 of these 3x plus 2 sides plus 2 of these 2x minus 9 sides, all adding together to equal 50. But if you don't see it like this, if you're like, I want to add all 4 of these things together, because that's how you get a perimeter, is you add up all the sides, you know, be my guest. You can do 3x plus 2 plus 3x plus 2 plus 2x minus 9 plus 2x minus 9, and you'll end up with the same thing. Okay. I'm going to do this so that we can practice our distribution, and that's 2 times 3x, that's going to be 6x. 2 times 2 is 4. That's going to be 4x here, and negative 18. And, okay, I'm going to start to combine some like terms. 6x plus 4x, that's 10x. 4 minus 18 is going to be negative 14. Okay. Now I got to solve at x, and I'm going to start with adding 14 to both sides. Okay, and then I'll have 10x equals 64, which I can divide both sides by 10 to get at x, and that's going to be x equaling 6.4. Okay, now we want, oh, and pardon me, I didn't say this. I could also, I want to point out that 64 divided by 10, perfectly good response. What would that be? 32 over 5, another good response, right? That's a simplified version of 64 over 10. What I don't want to, I'm not going to say what I don't want you to give me. What I want you to get away from giving me is 6 and 4/10 or 6 and 2/5, like a mixed number, because eventually you go to a place, AP Pre-Cal, AP Calculus, where sometimes the readers in the free response, if you write 6 and 4/10, they could read that as 6 times 4/10, and we don't want that to happen, right? Because that would be a completely different number. All right, over here. What values of a and b will the equation have infinitely many solutions? Okay, that's 3a minus ax plus b equals negative 2 plus 5x. Okay. And infinitely many solutions means I need to be identical on both sides, and that doesn't really look like an equals, so I'll change it like that. And so this one was a little tricky, so I gave you a little bit of training on it in class before you took the quiz, in case you forgot. What we need is we need the exact same thing on both sides. So I need 5x and 5x on both sides. And I need negative 2 and negative 2 on both sides. But from numbers, I've got this a and b thing going on, and we're not doing any systems yet. So what we need to do is start over here, match up the x's. I need negative ax to equal 5x, which means to me that a is going to have to be negative 5. Okay. And then now I'm going to plug back in on a. So I'll have 3 times negative 5 is negative 15, plus 5x plus b equals negative 2. Okay. Now I know that the numbers need to be the same, so negative 15 plus b needs to equal negative 2. Okay. And just think of, I mean, if you want to add 15 to both sides to solve at b, great, that's a good way to solve, right? That's the official algebra way. But also, if you want to solve this one with your eyes, think about a number that you could add to negative 15 to get negative 2. Well, I think that's going to be 13, right? Just however you want to solve it. So that's b equals 13. So I'm getting a equals negative 5, b equals 13. Okay. Then we're going to solve this inequality down here. And I'm going to just be fair to all 3 sides. Whatever I do in the middle, I have to do on the outsides too. So I'm going to get rid of this divided by 5 by multiplying all 3 sides by 5. So that'll be negative 5 less than or equal to 2x minus 3 less than 5. I'm realizing I think I made another error over here. Yep. Okay. Man. Again, 23 minutes in, I'm not going to just hit stop and re-record. So I'm seeing that I made a copy error, okay, the lowest in the taxonomy of errors. But this is fixable, right? I can go over here. I can say, all right, this was less than or equal to. This needs to be less than or equal to. That's going to be less than or equal to. And nothing really changes that. That's going to need to become a less than or equal to, which means that this is no longer a parenthesis, but a square bracket, and that this hole would be filled in, okay? Pardon me. I'll try to put those little like commentary things that flash up on the YouTube video that says like, hey, I know there's an error here, because that's pretty rough, but it's okay. Nothing I can do now. I'm going to add 3 to all 3 sides of this inequality, and it'll be negative 2 less than or equal to 2x, which is going to be less than 8. And then I'm going to divide everything by 2. What's wrong with my pens? Okay, that seemed to help. And then I'm going to get negative 1 less than or equal to x, which is less than 4. So that is an inequality. Okay, as an interval, it's going to go from negative 1 to 4. We're going to include negative 1, so it'll be a squared bracket. We're not going to include 4, so it'll be a parenthesis. And then, okay, so negative 1 up to 4. We are going to include negative 1, so we'll fill that circle in. We're not including 4. We're talking about the x values between those numbers, and then when we indicate that this is part of a larger environment where there are other numbers outside there that we're not including. Okay, that's my sketch. All right, that's all for Algebra 2 Quiz 1.1. Thanks for watching. Hope it helped.